Good morning, all. Have you all had an apple? Yes? Because I don't want you to go hungry. Are there developers in here? People who are currently developer? Not so many. Any architects? I will not make it difficult, don't worry. My talk will be about the relation between product and process. I will start by a short introduction in the key concepts that I will be using. Then I will tell you about the company, the product company that I worked for and that I look at for 4 teams where they are working in different ways, and this is related to the product that they are working on. First, a picture. You can't see it so well because it's very light in here and it's not that sharp. But does anybody see anything weird in this picture? Any can't tell. Nobody? Yes, this is a bridge into nowhere. It's not connecting anything, it's not bridging anything. This here is one of the busiest roads in the Netherlands. It had 6 lanes, and there was a traffic jam every day. Every day, some 140,000 cars are passing this road. What they wanted is have 6 lanes in both directions. But that didn't fit the old bridge, so they wanted to build a new one. Now, building a new one took 2 years. Now, what do you do when you build a new bridge or build anything? You fence off your construction site. Said, no, we are building now, you can't go here. There is 140,000 cars passing every day. So you want to have a detour for 140,000 cars. That will be, let's say, your standard process of building a bridge and making things still work, a detour. That was a bad solution. This is too much traffic. So instead of building a bridge at the location where it is to be used, they built a bridge next to the place where it is to be used. So for 2 years, this thing was being built up next to the place where it actually had to be. It's a 250 meters long bridge. This thing is big. Then in 6 hours' time, it was moved for 400 meters. It was moved on, let's say, pretty big cars. Next, it ended up there. Why am I showing this? If we will just focus on improving a process, a standard process, we will think, what is the best possible detour that we can create for all those cars passing? What was done here is create a different product. Instead of building a bridge, they built a deployable bridge. So by changing your product, you can affect what is possible in your processes. That's my basic issue here in this talk. Okay, I want to just give, let's say, a few key concepts that are relevant. Organization can be anything. Can be a team, can be a company, can be a department. Just call it organization. We might call a group of people that. In this organization, people try to get to some result. They have a goal, they try to accomplish it. To accomplish that, they follow some processes. So we can talk about processes that this organization is following. Now, if we take organization and processes together, then we get what is covered by agile frameworks. Frameworks are all about having best practices here, having good roles that can work together in your organization, having processes that work all in order to create a product. Now, we'd like to create any product. Because if you can create any product, then you can become certified, you can be trained, you can sell yourself in the market as a specialist, and you can sell yourself to everybody who wants to create something. You're not limited to a certain set of products. And I think that is the reason that not so much attention is given to the architecture of products when we are talking about what works in teams, what works in software development. Now, who is familiar with Conway's law? Who has seen this before? All right. Conway's law from 1986, if I'm not mistaken, says that, well, organizations that design systems are constrained to produce designs which are copies of the communication structures of these organizations. That's a bit abstract. Okay, more concrete. If you have 4 groups working on a compiler, you will get a 4-pass compiler. This is from Eric Raymond, meaning all 4 groups will say, we create our own pass. We create our own piece of the flow of compilation, because that we can control. Then we can be autonomous. Now, the thinking that I want to get across here is we don't need to be constrained in saying, well, we have organization, we have processes, we can build anything. We can think from the other direction. We can turn Conway's law around. We can say, if we make our product in a certain way, then we can adapt our organization to fit that way of creating our product. We can fit our organization to the architecture of the product. My case studies come from a company named Evolution Gaming. And does anybody of you know what live casino is? Not many. Before I started working here, I had no idea that this even existed. Now, Evolution Gaming is a company with some 5,000 employees, of which some 3,500 in Riga. And most of those are game presenters. They are beautifully young people who are elegantly dressed, and they are playing games in front of a camera. For instance, roulette here. They are sitting on floors that are completely filled with roulette tables, card tables for baccarat, poker, blackjack, and there are no customers. The customers are playing the games on tablets, on mobiles, on desktop computers, laptops. So we have live streaming of what is happening in the studio. Live streaming we see here at the top of what is visible in the tablet. Under that, we see a representation of the game, in this case of a roulette table. So this is the real thing, here is the generated thing, in order to be able to actually make a bet on a certain number. because Evolution Gaming is a gaming company. You can actually bet, you can win money, you can lose your bet. Now, in my role as Scrum Master lead for Evolution Gaming, I was asked to tell something about our processes to new people in the engineering department. The engineering department is some 300 people in total. When I did this the first time, I told something about our general processes. This is the kind of thing we do. We do Scrum. We also do some Kanban. So I thought about Scrum, I thought about Kanban. This changed after I got feedback. I thought, well, I should not keep it too general. I should talk about what teams are really doing. And from talking about what teams are really doing, I got to thinking, why are they doing it this way? So for context, the first time I talked about, we have organization, we have a product owner, we have a Scrum Master, we have a development team, we have sprints, we have daily stand-ups, we have retrospectives, demos, plannings, we have a 2-week release process. And this introduction was completely useless. Because the new joiners of the engineering department, well, they join on this day or that day, so in the end I'm giving this introduction after they have already been working for 2 weeks, for 2 months, and they have already seen in their own teams what they are doing. I'm not helping them. The one thing that was good is that I was telling them, well, whatever you may actually do, we want to inspect and adapt. We want you to be engaged in improving our processes. So you have a certain freedom to form these processes together with others. You also have a responsibility to participate in this. So in my next iteration of giving the introduction, I thought, oh, I should not talk about general concepts. They might already know that, or I'm not helping them anyway. But what will help them is understanding what other teams are doing, what options others have taken, what improvements in their process others have come up with. Because some teams were using Kanban instead of Scrum, or they had no Scrum Master. Or they had a QA who was doing some Scrum Master duties, but not all. There were all kinds of project management tasks fulfilled by product owner, maybe by Scrum Master. Instead of a 2-week release cycle, there were teams that could just release when ready. Also something different. In some situations, there was no sprint planning. OKRs were used, meaning we plan over a period of 3 months, objectives and key results. What do we want to accomplish? How do we measure how far we got? In different teams, we found different preferences for communication with other teams. In certain teams, they say, if you want to reach us, come to us or write us on Slack. In other teams, they say, if you want to communicate with us, we must have a Jira ticket, and then we can follow up in comments in Jira. And actually, there are good reasons for both. Both are working. Then, of course, different teams have different results of their work. Some are really creating products. Others are creating, well, infrastructure as a product, or and some are creating really services to support other teams. So this was more interesting to the new joiners. What are other teams doing? Well, when I started telling about other teams, I got into details. This team is doing this team is doing that. Then, from the new engineers who were already in teams, of course, I got feedback and learned from them what they are actually doing, or the things that they found good or bad, or perhaps just noteworthy. So I learned from my presentations. Anyway, so I learned, and I got to thinking, why do we have this division into teams? Why are they not organized differently? Why is the cut among grouping of people not differently? And is there a better explanation for the actually followed processes than iterative inspection and adoption? Because my original position was, we just have our general approach. You have your responsibility, you have your freedom as a team, you form your own processes. And then, as an outsider, my hands are off. You can do whatever you want. You go Kanban, you go Scrum, you go OKRs. It's not up to me. So I kind of had lost track of where they ended up. I could only say this is the process according to which you got to where you are now. But I couldn't say, I understand why you're there. And I got to thinking, well, what is the role of the product these teams are working on in all this? Now, Evolution Gaming, the company I'm talking about, is still scaling from being a startup. It's 13 years old now. And you see in many respects that, well, some startup elements are still there. Now, if you take a startup like the team on the left, the little ball, you said, these are not so many people. Small means few people. Let's say 10. Let's say a size that you can still see. Let's say even one Scrum team. You can work together. You know what you want to accomplish. You talk about it. You do it. Now, you get big. You get 300. So in an abstract way, I got to thinking, well, we have these 300 people in engineering. Now, what would the situation be if there were no teams? They are just 300 people doing everything. They are talking all over these 300 with each other. They are all in some way, let's say, responsible for the total result. They all have to adapt to each other in order to be able to work smoothly with each other. They all have to understand each other's work. So we can understand this is too much. This is too much for a person to be able to work effectively. We get an overload. So we don't want to have one big team of 300 people. That's not the way to scale. We want to have multiple teams. And preferably have all communication and responsibility bundled as much as possible inside one team, per team, and have less communication between teams. Now, how do we create different teams? What are the responsibilities of a team? Why are they separate? So This is a map from the Portland Police Bureau. This is about what different police teams are responsible for in surveilling. So this team is responsible for this piece on the map, the streets that are there, the houses that are there, the shops that are there. We have a natural separation of responsibilities. We can draw it on a map and we can easily explain this is what you are responsible for. Now, with software, we don't have a natural separation. We can say, well, this is kind of given, or we can say, this is database, this is separate. True, that is possible. But on the other hand, software is quite fluid. We can change how we organize what is hanging together. We can change our architecture. Good. This is all still quite abstract. I said I will look into what 4 teams are doing, seeing if I can make sense of the relation between what they are working on, their product, and how they are working on it. So Evolution Gaming is providing live casino. It's providing different games: roulette, blackjack, poker, baccarat. So the first team, or rather type of team, is a games team. One team is creating roulette, one team is creating blackjack. So I call them here archetypical game team. Second team, second type of team, of which there is only one, is the video team. Everything in live casino depends on live streaming. Live streaming should be perfect. If it doesn't look good, people will not want to play these games. It's not like you go to the tech servers and you say, well, as long as I can fill in my forms, I'm relatively happy. People will play a game because it gives them satisfaction. They must prefer it over doing anything else. So everything must look and feel really smooth. Everything that can be improved about the quality of video will attract people more to our games. Then, I say it in plural now, but we have, let's say, shared code. We don't have just roulette, baccarat, the things that you can see. We have some code that is more underwater somehow or really shared somehow. So there are teams that provide a platform on the back end and on the front end. Last, Evolution Gaming, well, let's say it was hedging its bets. Because maybe first-person games might work better than live gaming. So we should be in that market too. So RNG here, random number generator, it stands for we are not streaming anything live, we are creating a 3D animation of games. The team that was doing this had a changing position. I will go into that as the last of my cases. So the archetypical game team, they are creating new games. Quite often, this is a variation of a game. We already have roulette, but now we have roulette with 2 balls. So this is about features. It is about what you can actually see. It's about what players will actually experience. Additionally, they maintain existing games. They are using, all of them, a Scrum framework. They are all of them on a 2-week release cycle, partly for technical reasons, because all of the software is bundled into a monolith once in 2 weeks, and then released to production. The composition of the teams is cross-functional. We have graphical designers, business analysts, front-end and back-end developers, and QAs. They work together to get to a next iteration. Then we have a natural split, the kind of thing that we saw in the Portland police precinct overview. Because, well, roulette is something different than blackjack. The video team, the team that is supporting the streaming video, is completely different. So the streaming video and the interaction of the game, I showed you on the picture in the user interface. At the top you saw the streaming video, at the bottom you saw what the interaction is. These are brought together in devices, whether mobile phones or anything, into a playable game. So they are integrated, they are developed separately, then put together to make a single experienceable application. This, again, like the different games, is a relatively natural split. Because, well, streaming video is a different thing than making features of being able to bet on an outcome of a roulette wheel. Now, this video team consists of some 30 people. There is no product owner. There is no Scrum Master. Partly, these are specialists working on quite long-running R&D projects. Can we squeeze some better performance out of one aspect of the video streaming? Additionally, some people are providing support for specific features or problems of games teams, which is a completely different thing than doing research. The team is releasing when ready, because it's on a separate track from the games with regards to deployment. Now, they have numerically specified goals. They look at metrics, they look at statistics and say, okay, 10 seconds out of 100,000 seconds, our video image is stuttering, is freezing. We want to go back to 3 seconds of stuttering. If we can improve that, then the user experience will improve. So they are driven by numbers. Then for research, they are again number-driven and say, well, our objective is to, for instance, improve the experience of the sound of the video. We don't want any loud noises to suddenly become audible, because that is a thing that can happen in a studio. We want the sound to be such that it remains pleasant to gamers. This can all be measured, and we can specify, we want in 3 months this measurement to be better. But what you have to do for that is not to be specified in a number of user stories or tasks. Just see what you can do technically. Maybe use a new library, maybe improve an existing one. Now, I want to put them next to each other. So we had the games teams, we have the video team. In the game team, we have a releasable product as an outcome. They work on their roulette version. After 2 weeks, there is a new increment, and some new features can be, let's say, checked. This is there now, this is there now, this is there now, and a few defects are fixed. Multidisciplinary effort. So together, they create their new features. Together in different disciplines, the team creates new features. When working on development, there is a certainty of an outcome of it. You want to create a new dialogue and make a variable changeable by the user. This is just going to work. You specify it, you implement it. There is no chance that this is not realizable. But there is uncertainty about the value of your work. Yes, your dialogue is there, but is this really what players want? So here you want feedback. You want to show what you have created and then get feedback from humans, from people who are actually playing, or of our, let's say, experts in the company. Well, how does it feel to you? You may have asked for something, but now you can actually try it in a demo. Do you still like it? In a video team, the outcome is a measurable improvement. There is not so much need for people to give feedback. Second, we can just measure it, so when you have done your work, we wait for the statistics to come in. Was the work good? We can see it in the statistics. With research, there is uncertainty about the outcome of the work. So you might have tried something for 6 weeks. Sorry, didn't work, didn't give the result. We can measure it. You wrote a lot of code, you changed things, used a new library. Didn't work. So there is uncertainty. But there is certainty about the value of what you do. We wanted to get down the seconds in the total time, or let's say the number of seconds out of 100,000 seconds that the frame is freezing, and we got it down. That's all we wanted. The lesson that I learned from looking at this is that they have really qualitatively different goals. It's not just a matter of you do this and I do that. We separate the tasks out of a total. It might require, let's say, a different mindset. Are you trying to work on the basis of uncertainty and improve some number? Or are you just creating feature after feature? Right. I said there is a natural division of games teams, because on the front end, let's say for people playing the game, that is visible. So therefore you have different teams. They are separate. But part of functionality is shared. This is shared especially after some time. Meaning, year after year, you find that there are common aspects of your different pieces of code. These common aspects you bundle. You get a platform. Now, I want to skip the front end because I'm running out of time. But on the back end, we have more work on an architecture. People working there are explicitly thinking, how do all these systems hang together? A second thing of these teams is they can impose on games teams an API. They can impose an interface on other teams. They say, you just call our software this way. You have to comply with what we demand. That's a different way of communicating than just talking with people. Then it's relatively easy to create automatic tests for a backend. So typically, on the backend and in platform teams, they don't even have QAs. I'm not sure that it is a good idea, but that's the reality. Now, if two games teams are sharing code, there is uncertainty about what they are sharing. In the shared code, whose responsibility is it? You broke my code, I want some change, but it's not worth anything to you. When will this be done? Will you do it? Will I do it? Because the different teams have their own backlogs. Now create a platform, a new team that does this shared code. This team will have its own backlog, meaning that what is shared will have its own backlog. I said it. So there is some transparency on what is planned. A second is, if you need to negotiate over features, there is a product owner for the shared code. Rather than two product owners of teams fighting with each other, there is one who says, well, this is my domain. So in two ways, you have a simplification of communication. One is you have the interface. So instead of talking about everything, you have code, you have software that says what is possible. A second is you have communication to a central point. Because if you have two teams sharing code, that's one thing. If you have 7 teams sharing code, all wanting something, it becomes a nightmare. Okay, I will skip this. I talked about, let's say, the 3D games. Now, there was one team working on this. This was technically innovative, new architecture, anything could change on backend and frontend. No integration with existing code, but the scope is already defined because the existing games are, in a way, created anew, but fully in software without streaming. One team, one product owner. When this started, we say everything can change. So the team should be able to reach all code, change it all, not have discussions, not find other teams say, no, this is not allowed. But after creating several, we get a maturation, we get crystallization of functionality. And we find, hey, also in these games, we can find a common backend, we can find a common front end, and then what is left is 3D and a specific front end. So instead of having a separate team for this innovative part, we move to having the games teams doing the 3D games too. So this work was split from having one team do it all to different teams, to existing teams actually. That was possible because of an architectural change. Now, this is my conclusion. So what have we seen? Well, the architecture of our product can influence our processes. Teams can become more effective by having, let's say, their own realm, their own domain. We can reduce the need for individual interaction by having interfaces of code. We don't have to talk about everything. Here is a given API. We have an allowing of specialization, because that is made possible by saying this part is your responsibility. Just make it as good as you can. We can increase the focus of a team, not working on numerical things and on features, but saying, okay, we do the numerical things, you do the features. Or we can turn it around. In the last example, I went from one team can change everything to we have separate responsibilities. We can say, hey, let's have one code base and a team can change everything. So we can extend the freedom to change code by having a different architecture. So what I take out of this is where we can possibly apply this way of thinking. If for teams goals are confusing and processes are too complicated, or if a team is not productive, then see if a change of your product can help. Because if you change the architecture of your product, you might get new possibilities in having processes that work for a team. That's it. Thank you.
Thank you. Do we have questions from live questions from the hall? If no, let's move to Menti questions. Oh, sorry, there is one question. Okay.
Hi. How are you managing dependencies between your game teams and your core or teams? I see your core teams as
Yes.
not product teams, but component teams.
Yes. No, it's okay to say component teams. It's a combination of putting things in Jira and negotiating about the moment that things are done, or whether things can actually be done. There is no final arbiter on this. There is nobody who loudly says, this is what has to be done. I'm responsible for making the decision here. So it's a bit of a consensus model. Does that work? Often, yes.
Does that answer your question? Okay, next question. Don't you think that it could be less communication between teams if you would have microservices instead of monolith? Which team is responsible of testing monolith integration?
All right. Evolution Gaming is moving to a microservices model. So one after the other, the services are kind of lifted out of the monolith. This is a process of well, already a year, and more time will go into it. Who is responsible for testing monolith integration? I think most monolith integration. Yes, sorry, I was thinking of the microservices. There is a release team at this moment that is actually checking the monolith for 1 week before it is released to production. So if the released QA team finds any issues, they go back to the, let's say, responsible teams responsible for the code, who might have to fix it before it goes live. This is changing now at this moment. This release QA team is being disbanded, and teams are becoming responsible fully for their own games on production. You build it, you run it.